This is the last and final video for the quantitative tools for human resource management. And so I'm using data from 10.24, the supplement to Chapter 10. This has to do with work sampling. Work sampling is different than time studies. Time studies give you an actual time that it should take to complete a particular task or activity. And so it's much more precise. Work sampling, on the other hand, is just to get a general sense whether we're overworking our workers or we're not, underworking them. If they're idle too much of the time as compared to being idle very little time. Most of your homework problems approach it, I guess, from a positive standpoint. They look at idle. The homework problem that you've been assigned, the bank manager wants to determine whether his workers are 15% idle. He considers that to be acceptable, so that they are working 85% of the time. 15% of the time they could be doing something not work related. This one is a little bit different in that they're evaluating a machine. They want to make sure that this machine is not being overworked, and I guess connected to that is the idea of workers too, that if a machine is being used 100% of the time, that means there's a worker using that machine 100% of the time. So they believe that the machine should be idle 20% of the time, or that the worker shouldn't be using the machine 100% of the time. That will wear out the machine won't be allowed to cool down, fatigue will set in on the part of the worker, they may create accidents. So there should be a little bit of a break in between things, and so he wants to make sure that 80% of the time the machine is being used and there is a worker there, and 20% of the time it's not. Some of the other parameters that we have here, they want to be fairly confident. A 98%, 2.33 is what it translates into the Z value. Remember, you can look up those values in your textbook on page 416, table S10.1. They give you some of those, and so but this one's kind of unique. It's 98%. That's a 2.33. That is the Z value. And then H here is that they want to be, so not only do they want to make sure they capture 98% of the distribution, but they want to be within 5% of the results. Now this looks very similar to when we were doing time studies and determining the sample size we need to do to get an accurate time study. But it uses a slightly different formula because we're looking at percentages. Remember, this is less precise than time studies. It just says, tell me how many observations I have to make. I will make those observations, and then I will calculate the percentage, and that percentage will meet these parameters. I will be 98% confident I've captured the distribution. Will be within 5% of the true results, and based on the fact that I'm trying to assess whether the machine is idle 20% of the time. So given these parameters, they'll tell you how many observations you have to make. You then would calculate out of those many observations how many times were idle. That would give you the percentage, and then you compare. If it was greater than 20%, we may need to try to cut back a little bit. We may be overworking, or if it was greater than 20%, we're not working the workers hard enough that there is more idle time than we need. If it's less than 20%, we may be overworking them, is the idea. But the only way we can determine how many observations we need to make is by using this formula. Now, we do give you that formula on the formula sheet as well. So on the formula sheet, once again, not to confuse it with the sample size, these are how you calculate traditional sample sizes for time studies or for any other research project. So you could use these. These are related to your basic statistics. How many observations do I need to make to determine to fit within the parameters? This is a specialized formula just for, now there are some similarities, but this one is designed just for work sampling and for calculating those percentages. So you want to use this work sampling size N, and it will tell you what your N needs to be, how many observations you need to make. And so we will be using that formula in regards to calculating. So let's go back here and use the data. So it's just a matter of plugging these in. Once again, I'm going to do it in various pieces here. The first thing that they want you to do is square the z. So let's do that. We will use the caret sign in Excel. We're going to square that. So the exponent 2. So we've squared that. We're then going to multiply that by the percentage, and then we of course will multiply that by 1 minus the percentage. So here's where it gets a little interesting in that regard. We're going to, so the percentage here is, I'm going to just do it underneath here. We will do this where we will take the percentage. Like I said, you could flip this. We could see, we basically get the same answer, that that 80%. It's just, what do you want to focus on? They decided to focus on idle as compared to working, and so we're going to multiply that by 1 minus the percentage, which will give us 80%. So the opposite of that. Oops. And then we're going to multiply that by our squared z. So that's the top part. The bottom part is, I guess we could probably do this in the final, but it's squared h. So let's go ahead and do that. So I'm going to do this. I'm going to square the h. And now if I simply take this and divide it by this, what it tells me is that I need to do 347, 348 observations. And so once again, I'd go in and do that. And they need to be random, so multiple times during the day, multiple days of the week. I would make 348, 347 random observations, and then I would say, okay, yes, the machine's being used, or no, it's not. And then I would take the no's and divide that by the number of observations, 347, and that would give me my percentage. And then I can make that comparison. But this would allow me to be accurate. By doing 348 observations, I would meet these parameters, being 98% confident and within 5% of the mean, looking at a 20% idle rate. And so once again, if I made those many observations and determined that 20% of those, then everything's great. If it's more than that, then my machine is being idle. I probably need to make sure that my workers are a little bit more productive. If it's less than that, I'm probably overworking my workers and the machine, and so I would need to make changes. And so that's work sampling.